Part B, does it converge? The sum n equals, we have to start at 2, otherwise we get 0 in the denominator. The sum n equals 2 to infinity of 1 over square root of n minus 1. Okay, so write down the nth. Notice I'm not calling it an or bn because I don't remember. In the statement of the theorem, or the test, I don't remember which one's which, and I don't care. So I'm just calling it the nth term formula. You have to write down the given nth term formula and compare it with something. So 1 over square root of n minus 1. This is step 1, and there is no sigma notation in sight. It's just the nth term formula and the formula you're going to relate it to, which will be the nth term of the simpler series, right? It'll be a simpler formula, in other words. Okay. What makes sense to delete in this case? Bless you. The minus 1, but then what does that do to the denominator? Make it bigger or smaller if you delete the minus 1? Careful. You have to think of it. It's really easy to get the wrong answer on these, even though there's only 2 possibilities. It's bigger or smaller, right? It's really easy to think incorrectly when dealing with inequalities. It's just something about our brains. We do that. I do it. Everybody does it, almost. But wait, if you take away the minus 1, doesn't the denominator get bigger? If the denominator gets bigger, then the overall value is smaller. Okay, so that's what we want. So where do we want to put that then? We want to put it on the left-hand side. And I always start off right away. Where should it go? I'm going to use less thans. I'm not going to, if you look at like the answer books, sometimes they use greater than. That's confusing. I use less thans every time. Okay, and then I think about it ahead of time. Okay, if I delete this guy, then 1 over square root of n, that denominator is actually bigger, so it belongs over here, right? It'll be less than that guy. I better erase that. There we go. And then it's a less than, right? And if you want to be safe, you could use less than or equal to. I don't really care. But in this case, it'll be strict. And then what do both of these have to be bigger than or equal to? 0. Is it technically a strict inequality in this one? Is 1 over square root of n ever going to equal 0? No. I mean, that's its limit as n goes to infinity, but no, it's not. So, but is it still true when you put the or equal to underneath the less than? Yeah, less than or equal to means one or the other. Yeah. Okay, so that's the first step. Now, right at this point, with a little bit of practice, you should know what's going to happen. So you're going to look at the sum involving the simpler formula, 1 over square root of n, and you know what that does. It's a p-series again. What's p? 1/2, so that series is going to diverge. And because we constructed this thing so that 1 over square root of n is less than the given 1 over square root of n minus 1, we know that we're going to be able to use the comparison test and say that the original series diverges. After step 1, the whole thing is done. You just have to write it down, okay? You just have to write it down. Okay, so step 2. So step 2, you're going to write down the series n equals 2 to infinity involving the simpler nth term. And you make the statement. It's either going to converge or diverge. You guys told me it diverges. And then it's a p-series, so just parenthetically, what does p equal in this case? 1/2, which is certainly less than 1. That's the reasoning. It has to be bigger than 1 strictly for it to converge. Less than or equal to 1. Oh, maybe we should make this less than or equal to here. Because if you get 1, it still diverges. By the way, that's the proof that what we call the harmonic series diverges. This is an aside. Remember I just made that statement yesterday? That diverges because it's a p-series. P is, it diverges, D for diverges, because p is equal to 1, which is, of course, less than or equal to 1. So this guy diverges. We talked about that yesterday, but I didn't prove it because we didn't know about p-series yesterday. Okay, so back to this guy. That's step 2. Step 3 is when we make our conclusion about the original series. So what's your conclusion? So the sum n equals 2 to infinity, 1 over square root of n minus 1, that's all on the bottom, does what? Diverges by the comparison test. I suppose it should be capitalized. Now, again, the way you can go wrong on this is if whatever this guy turned out to be converged, it would tell you, well, okay, the sum involving that guy. If the sum and that guy converged, then it would tell you nothing about the sum of the bigger guy, would it? Because that sum is bigger. So you have to make sure if you're in this situation where the simpler function is smaller than the original nth term, you have to make sure you're looking for divergence. Otherwise, you're wasting your time. The comparison theorem's not going to apply.